Hello and welcome to Chapter 3, Section 2. Today we are proving that figures are congruent using rigid motions. So we're kind of going to do the backwards part of what we did yesterday. We can prove that two plane figures, which means they're two-dimensional, they exist on a plane, are congruent if and only if one can be obtained from the other by a sequence of rigid motions. So we can look at triangle ABC and triangle ABC prime and say, yes, they are congruent because I can prove to you that each of these 3 points went through the same transformations, which means it was a rigid motion, which means the shapes have to be congruent. Let's look at how that works. So in example 1a, we have two figures that looked like that we've reflected C, D, E, F over the y-axis. What we need to do is prove this. If you look at the lines between F and M, C and J, D and K, E and L, the y-axis is always the midpoint of those lines. You could also look at the coordinate notation. XY goes to negative XY. If all of these points follow this rule, then this is a reflection. And because it's a reflection, then shape JKLM is congruent to shape CDEF. Pause here and try it with B and come back when you're done. With B, they appear to be the same size and shape. So now you want to try and prove it. Can you map one to the other? Yes, because a counterclockwise rotation 90 degrees gets one exactly onto the other. The coordinate notation here has XY going to negative YX, which means this is exactly a counterclockwise rotation. It works for all 3 points. And because it works for all 3 points, then we can prove that XYZ is congruent to ABC. Try your turn, numbers 2 and 3, and come back when you're done. Number 2 is a straight reflection across the x-axis. Therefore, they are congruent. Our coordinate notation is xy gives us x negative y. And for number 3, that's a reflection across the y-axis plus then a horizontal translation. And because of both of these things, they are congruent. Our coordinate notation starts with xy, goes to negative xy, which is the reflection, and then we move it over 6. So it's 6 minus xy. In Explain 2, we're going to look at finding the sequence of rigid motions. And here we're looking at two shapes and we're essentially trying to figure out how did we move them to get from one to the other. One of the things that's easiest to look for is a mirror image. And is a mirror image a reflection or a 180-degree rotation? Those can be difficult to determine, and I really need you to look at the sizes of the angles in your triangles or your quadrilaterals or whatever it is that you have. Leave the smaller translations last. These are the two tricky ones, and if you can figure that out and then just slide it over and tell me how you slide it, that ends up being last. So, for example 2a, it's not a reflection, which means it's a rotation, and it's 180 degrees around the origin but they're not exactly the same distance apart from that origin. That's when you realize you've got to translate one to the right. So our final coordinate notation takes xy through negative x negative y and then into x plus 1 y. Have a look at B, pause here, and come back when you're done. We can check on how you're doing. You could make an argument for either reflection or rotation and then translation. However, the easiest argument to make is reflecting it over the y-axis first and then translating it up. So give numbers 5 and 6 a try. Pause here and come back when you're done. With number 5, it's a reflection across the x-axis, and then you translate it, x plus 4, y minus 2, so that this is your final coordinate notation. And then number 6, you reflect it across the y-axis, and then you translate it 0, and then y minus 10. So xy becomes negative xy, which is the reflection, and then x comma y minus 10 is that final answer. Okay? And the last thing we're going to work on is investigating congruent segments and angles. So we want to determine which angles or segments are congruent. And when we look at example 3, we notice that in A and C are congruent. B, the angle is different. And we can tell if you took that C line up any higher, you would know that that top line goes up and over the same amount once that C line hits an actual grid line. With letter B, AB is congruent to CD, which means they did a reflection and then a translation. There is nothing that transforms for EF. And then on your turn, we can see that angle B and angle C are the same, and that lines EF and GH are the same. Pause here and do elaborate numbers 8, 9, and 10, and come back when you're done. Number 8 is yes, it's the angle measure that matters. Number 9, yes, one can appear to be a dilation of another. And number 10 is maybe. If you map it with transformations and all but a few of the points match, then it's not going to be a rigid motion. But you have to be able to prove that. So, your homework for tonight is numbers 2 through 36 even. Give them a try. Let me know if you have any questions, and I'll see you next time.